Hey everybody, for this video we're going to talk about a new periodic table that we will use throughout the rest of the year in this class. There is a lot of information on this periodic table, so it can be overwhelming, but I'm going to talk about some things that you can highlight to make it a little bit easier for yourself. So here are the topics I'm going to cover in this video: diatomic elements, valence electrons, loss and gain of electrons, and ions. So the first topic is the diatomic elements. The diatomic elements have their own little key right here, so you can color that in. The diatomic elements are nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. So these elements are elements that will exist when they're by themselves. They will bond with each other. So right, what those will look like. So diatomic means two atoms. So what happens is the nitrogen will have a little 2 whenever it's by itself. Oxygen will have a little 2. Fluorine, chlorine, bromine, iodine, and hydrogen. So it means that these elements, when they're by themselves, not when they're in a compound, but when they're by themselves, they're so unstable that they will bond with atoms of each other. So there'll always be 2 atoms together of each of these. An easy way to remember the diatomic elements is that there's 7 of them. They make the shape of a 7, and the 7 points to the hydrogen. So that is an easy way to remember those elements. Now, what is stability? So stability has to do also with valence electrons. So valence electrons are the number of electrons in the outermost electron shell in an atom. So if you think of the structure of an atom, you have the nucleus with the protons and the neutrons in the center. Then there are electron orbitals where the electrons exist. The number of orbitals in an atom depends on the period. So period 1 only has 1 orbital. Period 2 has 2 orbitals. Period 3 has 3, and so on. So the outermost electron shell is going to be however many electrons are left over, not the inner electrons, but the ones in the outermost. So an easy way to remember valence electrons, I'm going to make a little key down here. So valence electron number is easy to remember because it also goes along with the group number. So group 18, these are the noble gases. Noble gases are very special because they actually are already stable. So they already have a full outer electron shell of 8. So 8 is sort of the magic number, and we call a full outer electron shell an octet. So an octet is like the magic number that every element on this periodic table wants to achieve. They all want 8 outer electrons. The noble gases all already have 8 outer electrons, so they are ideal. They are in the perfect form for all the other elements to want to achieve. So the rest of the elements on the periodic table besides the noble gases are going to bond with other things and create ions, losing and gaining electrons so that they become stable just like a noble gas. So what happens with group 17 is that these elements here in this group are all 1 away from the noble gases. So if you look at fluorine, fluorine has 9 electrons. Neon, a noble gas, has 10. Chlorine has 17. Argon has 18. So see how they're all 1 electron away from being those noble gases. The halogen group, or group 17, has 7 valence electrons. Group 16 is 2 away from having a noble gas configuration, is what we call it. So look at oxygen with number 8. It's 2 away from having 10, just like neon. So group 16 has 6 valence electrons. Group 15, 3 away. Group 15 has 5. Do you see a pattern? Group 14 is 4 away, so group 14 has 4 valence electrons. Group 13 has 3. We're going to skip the middle. The middle is weird. We do come back to it, but we're going to kind of skip over it for now. Group 2, 2 valence electrons, and group 1 has 1. So that is how you figure out the number of valence electrons for groups 1 and 2, and then 13 through 18. Like I said, the middle we'll kind of worry about later. So valence electrons, number of electrons in the outermost electron orbital. That's important because it's going to tell you what these elements are going to do to form ions. So the loss and gain of electrons is next. I am going to use red for elements that lose electrons. So everything from group 14 over loses electrons. They become more positive, so they are called cations. So there's a little T here that can try to help you to remember that cations are positive. So it's a little bit confusing that positive means losing electrons, but if you think about it, if you lose electrons, electrons are negatively charged. So if you lose electrons, that means you have more protons than you have electrons, so you form a positive ion. So what's going to happen here is that group 1 is 1 away from a noble gas. If you look at the periodic table this way, you can see that the numbers here, so the number for lithium is 3. If it loses 1 electron, it'll have 2, just like helium. Sodium has 11. If it loses 1 electron, it'll have 10, just like neon. Potassium has 19. If it loses an electron, it'll have 18, like argon. And it'll keep going. So rubidium, 37, krypton, 36. So all of the elements that are in group 1 all want to lose 1 electron. So we call this group +1. So that is the type of ion that group 1 makes. Group 2 is 2 away from being like a noble gas on the other side. So these all form +2 ions. If you notice, each of these elements on this periodic table have little +1s in the upper corner. They have little +2s in this one. If you look at the key here, common oxidation states, that's the big fancy word for it. You don't need to call it that. It's just the ion number. The transition elements in the middle, like I said, are weird and they do different things. Their numbers are, there's multiple. So manganese is like 5. Some of them only have 1, so that'll be important later on. We'll talk about those at another point in time. Group 13, as you can see, all does +3. So it's going to lose 3 electrons to become more positive. So that is the point at which all of these, and notice they're all metals, so all metals are going to lose electrons and form positive ions. That's important. Group 14. 14 is a little bit weird because they're sort of in the center. So at this point here, it's easier in terms of energy to gain electrons than it would be to lose them. So it costs energy to either gain or lose electrons, but it's really easy to lose electrons if you only need 1 to lose, or 2 is a little bit harder, 3 is a little bit harder. But this group 14 is either going to lose or gain 4 because it could go either direction. Okay, so at this point for group 15, 15 is when we're going to start to gain electrons. So here's a key. Blue is going to be gain electrons, okay? And when you gain an electron, you, where am I going to write this, are forming anions. So these are negative ions that are going to gain. So group 15 is 3 away from the noble gases, so that means that they need to gain 3 electrons. When you gain electrons, you're going to be more negative than positive. So you have a negative charge of -3. So the numbers I'm writing here with the pluses and the minuses are charges. So charges is going to be an important word. Group 16 is 2 away from the noble gases, so they're going to form a -2 charge. And then group 17 is just 1 away, so it's going to form a -1 charge. The noble gases do not form ions, so their charge is 0. All right, so that is how we label ions, valence electrons, and the loss and gain of electrons. So please use this video anytime you need help with that.